So in this video, we are quickly going to show how to factor differences and sums of cubes. To do this, we need a formula. And what this says is if we have a cubed plus b cubed, it's always equal to a plus b times a squared minus a times b plus b squared. So there's a really nice way of remembering the order of these pluses and minuses, and that's the acronym SOAP. So this first one is same. So if we have a cubed plus b cubed, we have a plus b in our factoring. Then the next one is opposite. So if we have a positive here, the opposite would be a negative. And the very last one is always positive. So regardless of what we start with, it's always positive. So this also allows us to make an equivalent formula for a cubed minus b cubed, because the same would be a minus b. The opposite would be a squared plus ab, and then the last one is always positive. So these two formulas will allow us to do these two examples above. So let's get to work. All right, so we have to identify what a and b are. So we know that a cubed is equal to 27x cubed. So if we take the cube root of both sides, then we have a is equal to, the cube root of 27 is the number that we multiply by itself 3 times to get 27, which happens to be 3, and the cube root of x cubed is just x. And then b, well, b cubed is equal to 1, so b is just 1. Pretty straightforward. So our formula says we're going to have a plus b, because it's the same, so 3x plus 1 times a squared, so 3x times 3x would be 9x squared. We have same opposite, so negative. This is going to be a times b. b is just 1, so we have 3x times 1, that's 3x. And always positive, we have b squared, which is just 1. So this allows us to factor it. Now you might be wondering, this is not a linear factorization. Can we factor it further? And this factor over here is going to make that difficult. Not impossible. The fundamental theorem of algebra says it's definitely possible, but it's not going to be easy because we would have to use our quadratic formula to find the two zeros, and then we could write those as linear factors. But for right now, I'm really just illustrating these two formulas, so we're not going to take that extra step to write the linear factorization. Instead, I want to come back and look at our second example, 8x cubed minus 125. So again, a is going to be the cube root of 8x cubed. The cube root of 8, pause the video, see if you can figure it out. Exactly, 2x. And b is the cube root of 125, which is 5. So again, following that same opposite, always positive mnemonic, we have a, so 2x, minus b, times a squared, so that's 2x squared, or 4x squared. And then we have same opposite, so a plus sign, a times b, so that's 10x. And then we have b squared, which is going to be 5 squared, always positive, is 25. So this, again, we have a linear factor and a quadratic factor, and we could not break that second factor down any further without the use of the quadratic formula. It's possible, not the most straightforward thing in the world, but once you have these formulas, it does allow us to do some really interesting things with cubic polynomials.